Imagine standing on a world where rain falls from an orange sky. Rivers cut through the land. Lakes and seas stretch toward the horizon. It looks strangely familiar. But nothing here is water. Not the rain. Not the rivers. Not the seas. More than 1 billion kilometers from the sun, there is a moon with weather, rivers, lakes, and seas. But its liquid cycle runs on methane and ethane, hydrocarbons that would be gases under Earth's conditions. This is Titan, Saturn's largest moon. And the closer scientists look, the stranger it gets. Titan is the only moon in our solar system known to have a substantial atmosphere. It also has something astonishing: standing liquids on its surface, moving through a cycle of evaporation, clouds, rain, and rivers. But Titan is brutally cold, around -179 degrees Celsius. It's so cold that water ice behaves almost like rock, and methane can exist there as a liquid. So those rivers and seas that look familiar from space aren't carrying water? They're carrying hydrocarbons. Methane evaporates. Clouds form. Rain falls. Rivers flow. Lakes and seas collect the liquid. It is remarkably similar to Earth's water cycle. Only here, the chemistry is completely different. And above this strange landscape sits an even stranger atmosphere. Titan is wrapped in a thick, orange haze. It is made mostly of nitrogen, methane, and complex organic compounds. Sunlight breaks molecules apart high above the surface. Those fragments recombine into increasingly complex carbon-rich chemicals. Some eventually drift down toward Titan's surface. For decades, this orange veil kept Titan's landscape hidden. Scientists knew something was beneath it. They just couldn't see what. In 1997, NASA, ESA, and the Italian Space Agency launched Cassini-Huygens. Its mission was to explore the hidden Saturn system. Cassini reached Saturn in 2004. Using radar and other instruments, it began mapping Titan through the haze. And suddenly, the hidden world started revealing itself. River channels, lakes, seas, dunes. But one mystery remained. If methane is constantly being destroyed in Titan's upper atmosphere, why is there still so much of it? Sunlight breaks methane apart over immense periods of time. That methane should eventually disappear. Yet Titan still has clouds, rain, rivers, and lakes. Something must be replenishing the methane. Scientists have proposed several possibilities involving Titan's interior. But the exact source remains uncertain. And that mystery was only one reason Titan demanded a closer look. Because Cassini carried something even more ambitious. A small probe named Huygens was designed to descend through Titan's atmosphere and land on its surface. On January 14, 2005, Huygens separated from Cassini and began its descent. For more than 2 hours, it fell through Titan's thick orange atmosphere. Then Huygens landed. It found a frozen, damp landscape, scattered with rounded stones made largely of water ice. The probe survived on the surface for more than an hour and continued transmitting data back to Earth. Humanity had finally reached Titan's surface. What Huygens saw on the surface was only part of the story. Because beneath Titan's frozen crust, something even more remarkable may be hiding. Evidence from Cassini and other observations indicates that Titan likely contains a global subsurface ocean of liquid water. It may also contain ammonia and salts. Above the ice, methane rain, hydrocarbon rivers, organic-rich dunes, and a complex atmosphere. Below it, a hidden ocean of liquid water. Titan is rich in organic molecules, the carbon-based compounds important to life on Earth. But there is still no evidence that Titan has life. That's why NASA is sending Dragonfly. Not a traditional rover, but a car-sized rotor craft designed to fly across Titan's surface and study its organic-rich materials. Dragonfly is currently planned for launch no earlier than July 2028, with arrival at Titan targeted for late 2034. Its goal is to investigate Titan's habitability and its prebiotic chemistry. If a world this cold can create rain, rivers, and seas, what other impossible worlds are waiting out there? Next time, we travel over 1,000 light-years away to Kepler 452b, a world once called Earth's possible cousin. Is it really another Earth? Subscribe to our channel. The next mystery is waiting.